Today, we're digging into a really powerful new framework for making sure AI systems are actually safe and accountable out in the real world. It's called AI control towers. So, yeah, let's just dive right in.
I want you to imagine something. This isn't one of those big, dramatic Hollywood-style AI failures. No, this is something much quieter, and honestly, maybe even more dangerous. It's what happens when an AI just slowly, silently drifts off course. So let's take a real-world example. You've got an AI at a bank, and its job is to approve loans fairly. If you just glance at the dashboard, everything looks fantastic. I mean, its accuracy is still sky high. But deep down, under the hood, subtle changes have crept in, and it's started to develop these new, hidden biases. And the real problem? Months later, the bank knows something has changed, but they have zero audit trail. They literally can't explain why the AI's decisions went off the rails. And that right there gets us to the absolute core of the problem with how we usually think about AI stability. Just looking at a performance metric and saying, hey, it's working, it's a dangerously incomplete picture. You see, for the longest time, we've only been focused on the tip of the iceberg, which is accuracy. We just keep asking, is the AI getting the right answer? But what we're missing is all the stuff lurking beneath the surface. Things like hidden technical debt, all the little untracked updates and shifts in data that just pile up over time. And this means a model can look perfectly accurate on the outside, while its internal logic is warping in ways we can't see or even predict. So to solve this, the research we're talking about today proposes a totally new definition of stability. And it all comes down to this one single sentence. True stability isn't about reproducing the AI's answer. It's about being able to perfectly reproduce the entire context and all the rules that led to that answer in the first place. And this is exactly what reproducibility of accountability means. The key question is, can you, at any point in the future, pull up one specific AI decision and see everything? I'm talking the exact model version that made it, the specific data it looked at, the policies that were active at that moment, and the reason it gave for its action. It's all about creating a perfect, tamper-proof audit trail for every single decision. Okay, so how do we actually do this? Well, the solution proposed is something called the AI Governance Control Stack. And honestly, the best way to think about it is like building an air traffic control tower for all of your AI systems. And here it is. This is the blueprint for that control tower. Now, this stack isn't just one single tool. It's a whole series of interconnected layers. Each one has a very specific job, and they all work together to give you complete oversight, from the foundational infrastructure all the way up to the point where a human needs to step in. All right, let's take a quick look inside this control tower. We're going to do a quick tour of the most critical systems to see how they keep the AI flying safely and on course. It really all boils down to 4 core functions. First up, you have to file the flight plan. This is your system of record governance, which locks in the exact model version and the rules being used. Second, you log the black box data. This is crucial. It's explainability logging, which records the why for every decision, not just the what. Third, you've got to monitor the radar. That's your drift monitoring, constantly scanning for any changes in the AI's behavior. And finally, you need your emergency protocols. The governance escalation layer gives people a clear, predefined plan to intervene when things start to go sideways. And this diagram just illustrates it perfectly. The control tower isn't a set it and forget it kind of thing. It's a living, breathing system. This life cycle shows a constant feedback loop. You deploy the AI, you monitor its telemetry, you detect any drift, and that drift automatically triggers tests, and if it's serious enough, a human-led escalation. It's a never-ending cycle of observe, test, and correct. Okay, but what about when AI gets more and more powerful? Well, this concept is designed to scale right along with it. Because not all AI is built the same, right? The more powerful the system, the more sophisticated and tough its control tower needs to be. And that's this idea of hardened governance. Just think about it this way. You would never manage a small, single-engine plane with the same level of rigor as a massive jumbo jet, right? It's the exact same logic here. A simple analytics model might just need some basic monitoring and documentation. But a frontier AI model, that's your jumbo jet. It requires intense, hardened governance with multiple redundant layers of safety and oversight. And this table just makes that idea crystal clear. It lays out a capability-aware model. See, for low-capability systems like basic analytics, simple documentation might be enough. But as you climb that ladder to generative and even agentic AI, that governance has to get way more intense. You start needing things like gated propagation, which means no update can go live without passing serious checks, and very explicit authority controls to make sure a human is always in a loop. You know, what this whole framework really represents is a fundamental shift in how we approach building AI. The job is no longer just about writing the code for the model, it's about engineering the entire control system that has to surround it. So let's just quickly recap the big takeaways here. First, and most important, true AI stability isn't about performance, it's about reproducible accountability. Second, we have to build this dedicated governance infrastructure, these AI control towers around our models. Third, these towers are made up of real, concrete layers for things like versioning, logging, and monitoring. And finally, the intensity of that governance has to scale up as the AI itself gets more powerful. At the end of the day, this whole thing isn't about holding AI back. It's actually about enabling it to become more powerful and more autonomous, but safely. The ultimate goal is to design systems where human authority isn't just some patch you add on later. It's a core, fundamental part of the system's architecture from day one. And that really leaves us with one final and pretty critical question. We are launching bigger, faster, and more powerful AI planes every single day. The challenge for everyone in this field is, are we building the control towers fast enough to actually keep up with them?